Hey, welcome to 8.6, Solving Exponential and Logarithmic Equations. So this is the last section of the chapter, and we're going to bring it all together in this section. So we're going to use all our different properties and a little bit of new stuff I'm going to learn today to solve exponential and log equations. So there's two types of exponential equations you're going to see, and those are on the front side here. And there's two types of log equations you're going to see, and those are on the back. So starting with the exponential equations, our goal now is to actually solve for x. So we're actually going to solve these now. Starting with example A, here's what I want to think of. Review a quick log property with you. If I have log base 2 of 2 to the x power, think in your mind, hopefully you all remember, what is that equal to? Okay, it's equal to x. Hopefully you said that. But that's kind of the goal I'm doing right now. I'm going to try to use this property to solve these. So here's what I mean. If I have a base of 2, what I can do is I can actually take log base 2 of both sides and what happens is this part, if you want to think of it this way, this part kind of all cancels and only the exponent is left over. So I've basically canceled out the base of 2 and now I've made it so it's just a regular x. But on the right side I've got log base 2 of 7. Not too bad using the change of base formula we just learned in section 8.5. So I can take log of 7 divided by log 2 and type that into your calculator. You end up with 2.81 approximately. We're going to round to 2 decimal places today, and we're going to be finding the approximate solution in every situation. If I left it as log base 2 of 7, that would be considered the exact solution. Now it says check for extraneous solutions. We're going to skip that for now in this video, and I might talk about that more in class, but for now we're going to skip that. Let's look at part B. So now I'm trying to get rid of a base of 4. So this time, because I'm trying to get rid of a base of 4, I'm going to take log base 4 of both sides. And so again, this whole part cancels, and I want to type into my calculator log of 15 divided by log of 4. It does get harder than this, in case you're wondering. Go ahead and try typing that in. You should end up with approximately 1.95 for that one. Alright, so here's what we do when it gets more complicated. You want to try to get the thing that is the exponential statement by itself first before you log. I'm going to call that the base, quote base. Get the base by itself before logging. I'll call it logging. That's probably not official. I can't touch the 2x and the minus 3 at first because they're locked there because they're in an exponent, so that I can't touch those until I've gotten rid of that by doing the log. So let me show you what I mean. So for this statement, first I'm going to try to subtract 4 from both sides, and I did not give you very much space to write for this problem C in particular, so make sure you write small for this one. So after I subtract 4, I get 10 to the 2x minus 3 power equals 17. Once I've gotten rid of the 4, now I would consider the log, or not the log, but the exponential part to be all by itself. There's nothing else left except for the base and the exponent. Once you're at that stage, that's when you take your log of both sides. Now this time my base is a 10, so I want to take log base 10. And remember, you don't have to write the base 10 because a log base 10 is the normal common logarithm. And we're going to do approximate solutions today. So go ahead and type into your calculator log of 17, find out what it is, and we'll just use that decimal as we're going through the rest of the problem. So when I type that into my calculator, I get approximately 1.23. On the left side, all of this has canceled, and now I'm not just left with x, so I'm left with that entire exponent 2x minus 3. And this is where we now go ahead and keep solving. So add 3 to both sides. Technically everything I'm doing from this point forward is an approximate solution. So I'll put a little squiggly and you end up with approximately 2.12 for your solution. Leave some space. We might come back and check that later during class. Why don't you pause the video and try part D, and then when you unpause it, we'll see how you did. If you have unpaused and you're checking your work, the question is, did you get negative 0.52? That's the correct answer for that one. Let's move on. So E is actually very similar to what we've just been doing, but F is a little different. So why don't we try F? And again, I'm going to try to get the thing that's the base by itself. The only thing is, for this situation, I also want to get rid of the 1/2 before I log both sides. So here I've got two things to do. I want to get rid of the 1. So I have 1/2 times 2 to the 2x power equals 5. And then I want to get rid of the 1/2. So multiply both sides by the reciprocal. It just cancels out this part. This part stays 2 to the 2x power. 5 times 2 is 10. And now I have the base and the exponent all by itself, and I'm ready to take the log of both sides. This time it's a base of 2. So I'm going to log base 2 of both sides. And remember, in your calculator, if I'm trying to figure out what log base 2 of 10 is, I'm typing in log of the top divided by log of the bottom. So when I typed that in, I ended up getting 3.32. On the left side, the log base 2 and the 2 cancel each other. I'm left with 2x, and so divide by 2, and I get x is approximately 1.66. If you feel like you need to try one more, go ahead and pause the video and try F, and your final, or not F, but E, I mean, your final answer for E should be x is approximately negative I'll do 3 decimals this time, negative 0.079. So go ahead and try E if you feel you need some extra practice. We just did the first type of exponential equation you're going to see today. So now we're going to do the second type. And the second type is happening when, instead of just having an exponent on one side, I've got an exponent on both sides. So if you notice, everything I did previously, I only had a single exponent going on, and everything else was just regular numbers. Now that I have an exponent on both sides, it makes things a little bit more complicated. I could potentially still take the log of both sides, but in order to make that work, in order to take a log of both sides, I need to have the same base. So our strategy for this is making each side have the same base, so I can take the log of both sides and make everything cancel except for the powers. So let me show you what I mean. We're not going to make things too difficult for you, so don't overthink it, but when I get numbers like 4 and 8, they're going to be in the same family. So what I mean is, it's going to be there'll be numbers that are 2 cubed, 2 squared, 2 to the 4th, 2 to the 5th, or 3 squared, 3 cubed, 3 to the 4th, 4 squared, 4 cubed, 4 to the 4th. You know, all numbers that have the same base, but they're just a different exponent taken to them. And they're not going to go too high either. So it's going to usually be in this range. Not always, but usually these are the numbers that they're using. And here's what I mean. 4 is the same thing as 2 squared. And 8 is the same thing as 2 cubed. And the reason I'd want to do that, and the powers haven't changed, so I'll just rewrite those. The reason I want to do that is because I'm going to have the same base now. But just a second, before I do that, I have power to a power. We learned this in chapter 7. When you have power to a power, you can multiply those. So on the left side, it's actually 2 to the 6x power. On the right side, I can actually distribute that power of 3 to both of those, so I end up with 2 to the 3x plus 3 power. And notice I now have the same base. And now that's important because to get rid of that base of 2, I'm going to log base 2 of both sides. And this is only going to work because whatever you do to one side, you got to do to the other. So it's only going to work if the bases are both the same. But since we made them the same, on both sides, those are going to cancel. Those are going to cancel. So I now have 6x equals to 3x plus 3. Awesome, because now it's just a super easy equation. So just solve it like normal equation solving at this point. I've got 3x equals 3, x equals 1 for my final answer for part A. I'm going to give you a few seconds right now. Look at the number 2 and the number 32, and your goal at this time is to figure out what family those are all in, I guess. Is it 2 to some power, 3 to some power, 4 to some power? And this is kind of a bad example, I guess, because this one's easy. 2 is already written as a base of 2. So if you can just think, okay, 2 to what power gives me 32? And it's 2 to the 5th. So 32 is the same thing as 2 to the 5th. And this one is already nicely written for us. So I'm going to distribute my 5 quick. So I've got 2 to the 5x minus 5 exponent there. And on this side, 2 to the 4x exponent. And that whole left side I never had to do anything with. So now I would take log base 2 of both sides. And a shortcut is, as soon as you get it so they've got the same base, the powers are just equal to each other. So I got 4x equals 5x minus 5, and then go through and solve it. I get negative x equals negative 5. Divide by negative 1. X equals 5 this time. Go ahead and look at C right now. See if you can figure out what my base is going to be. I'll give you a hint. The left side is going to be a 5 for the base. Alright, anybody got it yet? I am thinking in my mind 125 is the same thing as 5 cubed, so that's where my base is going to come from this time. I am going to now distribute this exponent, or multiply them together, I mean, which means I will distribute the 3. So I end up for this exponent, 3 times 2x is 6x, 3 times 3 is 9. So 5 to the 6x plus 9 power on the right. On the left, I've got 5 to the x minus 1. Last but not least, because it's a base 5, really what I'm doing is taking log base 5 of both sides. And I end up with x minus 1 equals 6x plus 9. Again, as soon as you get to this stage, easy equation solving. So I'm just going to quickly go through. I'm assuming people know how to do this part. But make sure you ask me in class if you struggle with the equation solving. Negative 1 minus 9 is negative 10. X equals negative 2 this time. As soon as you have that written down, go ahead and flip to the back and get ready to look up video number 2 for this section. Hey, welcome everybody to 8.6 part 2. So you're on the back side of your notes sheet, and on this side we're going to talk about the 2 different types of log equations that you're going to be solving. To start off with, I want to remind you of a property we learned, and that was if I have something like 3 and I take it to the log base 3 of x power, the property was the 3 and the log base 3 are inverses of each other, so they cancel is the kind of simplified way of saying it, and that whole thing would just be equal to x. So the reason I tell you this is if I can make it so I've got a base of 3 and the exponent is a log base 3, that part essentially cancels each other, and whatever is left here ends up being the answer. We're going to use that property in just a second. The other thing I want to show you is, let's suppose I had 2 of the same logs, so they're both log base b. On the left side it's x and the right side is equal to y. If this part is exactly the same base and everything, that means x is equal to y. So let me show you that with example 3, part A. So what I mean is, if I've got log base 3 on this side, log base 3 on this side, that means whatever is here is equal to whatever is there. And a more longhand way of doing it is, if I think about taking both as exponents of the base of 3, that cancels out the log as well. The shortcut again is, if these are the same, log base 3, it's kind of like they cancel each other. And now I have 5x minus 1 equals x plus 7. And then you just solve it. So when you do this again, as soon as you get to this stage, it's an easy solving equation. So subtract x from both sides. 5x minus x is 4x. Add 1. 4x equals 8. Divide by 4, and x equals 2. Let's try it again. On example B. So again, really what's happening is we're going to take both sides as exponents of the base 4, and that cancels both of the logs out, and I just have 5.6 minus x equals 18.4 minus 2.6x. I'm going to go through this faster than I did before, so again, make sure you ask me questions in class. This is me assuming that you are all pretty good at solving equations right now. I'm going to get all of my variables on the right side and my numbers on the left. I end up with negative 12.8 equals negative 1.6 when I combine like terms. Divide by negative 1.6, and I end up with x equals 8. Moving right along to example 4, so the other type of log equation that you're going to see. So what I did before when I took both sides as exponents of a base of 4, that's called exponentiating. And when I do this with logs, I do end up getting extraneous solutions sometimes, so we're going to check our answers each of these times. So here's what I mean. In order to get rid of a log base 5, what I can do is I can take both of these as powers of 5, and what I mean is both sides. So I took the left side as a power of 5, as an exponent of 5, and I took the right side as an exponent of 5. So whatever I saw here and here, I just made the exponent, both sides I made a base of 5. This works because now this part, 5 to the log base 5 power, cancels itself. I just have 3x plus 1 equals, and then actually do 5 squared, which is 25. Go through and solve it at this point. I end up with x equals 8. To check your work, we're just going to take our answer and plug it in for x and see if it ends up giving us a true statement. So this whole statement ends up being 24 plus 1, so 25. And if you need to, type in your calculator log of 25 divided by log of 5, but you end up getting 2. So check, it works. Alright, let's do part B. I want to tell you that when I'm doing this, I kind of like to do a shortcut, and instead of this, in this situation, you know how I rewrote everything? When I'm exponentiating, I often like to just write it here. But just know that what I have just done is I've created 4 as a base and 2 as an exponent. So on the right side, for example, 4 squared is now 16, and on the left side, those cancel. So don't be thrown off by my shortcut, and if you need to write it all out a second time, that's okay. So I end up with x equals 13 for this one. Again, go through quick and check it. So log base 4 of 13 plus 3, plugging it in for x. Log base 4 of 16, well, 4 squared is 16, so yep. Starting with example C, we get to some new things. When I exponentiate, you only want to do that at the very end. As much as possible, I want to get my log statement by itself first, and what I mean is I want to get by itself the log and anything that's locked inside the log. So right now, for example C, only the log of x is kind of locked together, but if I look at example E for example, I was going to say example E for example, but anyways, I can't exponentiate, or these are all together log base 5 of x plus 2. So I can't subtract the 2 off. That's locked with the log if there's a parentheses. But here the 13 is not in a parentheses with the x, so the 13 I can move. Let me show you what I mean. Alright, so subtract 7 from both sides. 5 minus 7 is negative 2. What I'm trying to say is, in a very longhand way, I can use a 13 in this situation because it's not being logged. It's 13 times the log, so I can divide it off. That is legal. That whole long thing was what I was trying to explain to you. And now, don't be thrown off by the fact that there's no base, because you guys know this. If there's no base and it's log, it's really the common log, so the base is 10. So I'm going to take both things as powers of a base of 10. In my calculator, I'm going to type in 10 to the negative 2/13 power. Don't forget to use parentheses. And you end up with approximately 0.702. Now, I'm going to stop with checking solutions for a little bit until it gets to be more significant with example E and F, just to save us some time. So in case you're wondering, I'm intentionally not going to check the solution for C and D. All right, let's move on to D. Again, I'm going to try to get my log statement by itself, so I subtract 13 from both sides. And in this situation, I also want to get rid of the negative before I do anything here. So to get rid of that negative, I'm going to divide both sides by -1. Alright, and now I'm at the stage where my log is by itself. This time it's a base of 2, so I'm going to take both things as powers of 2. So x equals whatever 2 to the negative 4th power is. And that is 1 over 2 to the 4th, if you remember our exponent properties, I mean. So 1/16 is our answer for that. It does get a little more complicated with E and F, so I hope that you're still tuning in right now. We're going to now combine our log properties that we learned in section 8.5 with the solving. Here's what I mean. Notice that for example E, I've actually got 2 different logs. We're going to want to combine those. I think we actually even called it combining, but we want to combine those, or maybe we called it condensing. Yeah, we're going to condense those into a single log and then solve it. And that's where that skill comes in that you practiced over and over and over again with 8.5. So think back to your properties, look back in your notes if you need to, try to remember a plus sign. What does that mean? Which property was it? It was a product property, which said if I see that plus sign there, both of these pieces get multiplied together. So now I have 6 times x plus 2 right here. I'll go through and simplify that a little more. So I'm multiplying these together, so I'll just go ahead and distribute that right away. So 6 times x is 6x. 6 times 2 is 12. And that whole thing is being logged. Once I've done that, now it's a statement just like the ones that we did earlier. That means I need to get rid of the log base 5. So I'm going to take both sides as powers of a base of 5. I end up with 6x plus 12 equals, and I'm going to type into my calculator 5 cubed, which is 125, and then I'm going to solve it. 6x equals 113 divided by 6 divided by 6. X is approximately 18.83. Now, let me give you a secret. The only time you're really going to have an extraneous solution, honestly, is when you end up with an x squared situation. So when you have an x squared situation is when it's going to be essential to check for the extraneous solution. In most other situations, you will not get an extraneous solution. If this is a quiz or a test, I would tell you specifically when to check your answer, so you don't have to personally actually know when you're doing it. And here's where our x squared comes from. Look at this. I'm going to try to condense this log statement. And when I try to condense this log statement, my first step is to move my number in front to an exponent. Remember, you do not move the negative sign, only the number. So now it's log base 7 of x squared. That's where my x squared comes from. Everything else I haven't touched yet. And now on this left side, I want to use a property and condense those into a single log. If you think about our properties, I got a subtract sign, so I'm thinking the quotient property. So I'm thinking log base 7 of 3 divided by x squared. And this is okay that I have logs on both sides because remember what we did with example 3. If there is a log with the same base on both sides, if I, for example, take both sides as exponents of 7, the base of 7, I end up canceling that and getting 3 over x squared equals 1 over 3. When you get an x squared, it will be an easy equation like this, where in this situation I actually can just cross multiply. So x squared times 1 is x squared. 3 times 3 is 9. And this is an easy one. Most of you, I'm expecting, know how to solve that. I can just square root it because a square root undoes a square. But when I square root something, I could potentially have 3 in here to make it a true statement, or negative 3. All right, so I've got two potential answers, and here's where it gets extraneous. So let's just check this really quick. If I put a 3 in up here, I'm going to run out of space here. So, but I'll try it. When I put a 3 in my calculator, I can type in log of 3 divided by log of 7 times 2, and shorthand, it ends up working. I might have to do this more in class because I totally ran out of space. But actually, let me just go down here a little bit. Okay, I'll just go down here a little bit. Now, when I try to check the negative 3, what happens is I end up with that situation I was talking about at the very end of our notes on section 8.5, which is when I get a negative statement right here. It's not possible because remember, this log statement is right now asking me what power of 7 gives you a negative 3, and it's not possible to take an exponent and get a negative if you started positive. If you started positive, there's no way I can make it negative with an exponent. So that is why that doesn't work. That means that the negative 3 is extraneous and only the positive 3 is our answer. So x equals 3, negative 3 was an extraneous solution. All right, thanks for tuning in, and please remind me in class tomorrow to talk more about this example F here if we need to. I'm probably not going to remember because I'm recording this video about 2 months in advance. Thanks for tuning in. We'll talk to you again soon.